Welcome to the problem section on proving identities, and we'll do quite a number of problems here. And as you notice from a lecture, they could be a little bit lengthy. So, doing the problems actually is rather quick, but me talking about them and writing could be rather lengthy. So we have quite a 20 to 30 minutes ahead of us. Let's get started. As I do in problem sections, they start out with the easy ones. So we're supposed to prove that tangent over secant is the same as sine. And I'm going to manipulate the complicated side first, which is the tangent over the secant. And I'm going to use the ratio identities for that. And then we'll see. So tangent is going to be the same, of course, as sine over cosine. So sine A over, let's see, I'm going to write it like this here, as a fraction. That's what I meant with rather lengthy. Sine A over cosine A. And then we divide that by, and let's see that, find a nice division sign here. Again, that little gray bar here is simply my box for the equation editor. So I'm going to have this one here, and then secant divide by 1 over cosine. Now I believe this looks really funky, really strange. I don't think I'm going to do that. I'm going to do it differently. Do this one. Do this one. And now it looks nicer. Okay, so again, what I used here was the ratio identity. And then, of course, we don't want to divide by a fraction, so we multiply by the reciprocal. So I'm going to have times cosine over 1. And of course I don't have to write that 1, but I do it anyway for completion. And then we can see that the cosine is canceling out on the left-hand side, and we're done. Sine equals sine. So here my last step that I did was multiply, obviously, with reciprocal, which is reciprocal, which is simply algebra. The trigonometry actually in here is rather basic. Well, what we need the most is the algebra. Okay, next one really looks the same, right? I mean, if there's cosine on the right-hand side, well, then it would make sense if the other functions are on the left-hand side. So this time the cotangent and then the cosecant. So this one again should be rather quick. I think I'm going to copy this one here. So this one is cosine, sine, and then here we have sine. And here I'm going to say ditto, see above. And here I will say the same. Copy this one. And we have cosine over sine. Sine equals cosine. Notice that I forgot to switch this one here to a cosine. There we go. Now it looks better. And we can see that the signs are canceling out. So we're done. And then I may want to add here multiply reciprocal. Cosine A cancels. Okay. Check with the graphing calculator. I believe I will just do one of these two here in a moment. Let me do the next problem set, and then I can just switch over to a graphing calculator and do two at once. Let's see. Prove that this next identity is true. Cosine times cosecant plus tangent equals cotangent plus sine. Here what I would do is, so it lets me do that, is switch the cosecant to a sine. So I'm going to have 1 over sine x. And I might as well switch the tangent also to cosine over, sine over cosine, because I can see that once I distribute the cosine in here, that the cosines will cancel. So this one here will be also a fraction of sine over cosine. And then I can see once I distribute this one here, that the cosines will cancel. So what I did here was actually the ratio and the reciprocal. And I wonder if I forgot that on the last example, write in the word reciprocal up there. Let's see if I did that. Yep. So here I used the ratio and the reciprocal identities. And here what this means, multiply with the reciprocal, is actually switch the fraction here to its reciprocal. Okay, so let's see what's going to happen next. Distribute the cosine in here, so we're going to have cosine x over sine x, and the other one, the cosines are canceling, so I think I'm just going to leave this out and save ourselves a step off instead of writing everything down, and then I don't need the parentheses. So here, distribute cosine x and in the second term cosine x cancels. I think I want to keep this together. There we go. And then I'm actually done, because cosine x over sine x equals cotangent x, of course. And we know that. Okay, this one again here, well, I almost said virtually the same, but not quite. There's a 1 here in the end, so we'll see what happens there. Let's see. Again, probably the same here, ratio and reciprocal. So here secant is going to be 1 over cosine. 1 over cosine. Cosecant is 1 over sine. There we go. Then distribute the sine x this time. And then you will see that in the second term, the sine is canceling. So distribute sine x in the second term. Sine x cancels. I'm going to do a semicolon here. Okay. Again, if there's a little bit off the page at the bottom here, just use the scroll bar and get it up a little higher. So there's a sine x here that is being distributed right there and right there. And then, of course, and then I take the parentheses away. I don't need them anymore. And then, of course, right here, this will become a 1, and this will become a tangent. And we can see that we're done. Okay. I'm going to go to the graphing calculator, and I'm going to do the last one on the graphing calculator here. And then from the previous example, I also will do the last one, which was the cotangent over cosecant equals cosine. So let's go over there. If I actually have the graphing calculator open. I guess I had forgotten about that. Okay, here we go. Okay, kind of clear. Get a little bit off here. This must be from my last recorded session. Okay. Let's see. I said the last one that I just did, which was sine times parentheses secant plus cosecant on the left-hand side. So I'm going to do sine, let's say, I think I'm still in radians. Yeah, I leave it in radians for time being here. So let's make it 1 radian, which I know is not a special angle. Only fractions of pi in radians would be a special angle. So I know that simply 1 radian is not a special angle. It's a little bit less than 60 degrees because it's a little bit less than pi over 3, but at least it's not a special one. So sine of 1 radian times, parentheses, oops, one too many, 1 over cosine of 1 radian plus 1 over, whoops, there's actually, this time around there's 1 parentheses too many right there, sine of 1 radian, and then close to parentheses that I multiplied with. That's the left-hand side, comes out to 2.557, and the right-hand side is tangent of 1 radian plus 1. Comes out to 2.557. So that way we checked the previous identity. The next one, the last one from the first example, is cotangent over cosecant equals cosine. This time, I think I just switch over to degrees. Just makes it nicer to look at because we're more familiar with degrees. Doesn't make a difference to the identity. All right, so it says cotangent, which of course is 1 over tangent. Let's make it 20 degrees. Divide by, I put that in parentheses because it was a numerator, divide by the cosecant, so again I put that in parentheses, divide by 1 over sine. I don't know if the graphic calculator might recognize it correctly, even if I left out the parentheses for numerator and denominator. Let's see, 0.939. On the right-hand side, it's simply cosine of 20 degrees, which is larger than cosine of 30 degrees, which is 0.866. We have that memorized, so it should be between 0.866 and 1, and that sure looks like it. So let's hit enter, and indeed that's what it is. So that identity was correct as well. Let's continue on with proving more identities. Okay. So let's see what we have here. Oh, now we're getting into some nice ones. Well, what are we going to do with this one? On the right-hand side, I would say 1 plus cosine squared. I could almost interpret that as a difference of squares, however, it's not a difference. So I better not touch it. Pythagorean, well, unfortunately, the Pythagorean would have to say 1 minus cosine squared as well. So I may not want to do that. Same thing in the denominator on the left-hand side. It says 1 plus sine squared, the same kind of deal. But this one here, the numerator right here, that looks like a difference of squares. I know it says quadruples, but that simply means take the square of a 4th power sine, and you come up with sine squared. So that's what I'm going to do. It's going to be 1 minus sine squared times 1 plus sine squared. You really should be familiar with the difference of squares that you were hit over the head with in algebra. So we're going to have 1 minus sine squared times, what happened now? Where am I? It's pushed me somewhere. There we go. All right. No, I lost my equation box. Here it is. Okay, and there should be a times here. Parentheses. There we go. And this here should be a plus. Okay, and then I can pretty much see what's happening on the left-hand side. In the next step, 1 plus sine squared will cancel. So I'm going to do that in the next step. So here, difference of squares. Still a difference of squares, even if I misspell it. Okay. And then, as we said, 1 plus sine square will cancel. So on the left-hand side, we have this one. One plus sine square cancels. A couple of things here to do. Power, and this one is a Greek letter. There we go. 1 plus sine theta squared. Okay, is that one the same? Well, let's see what happens. Let's see, maybe you know what, I should double check myself here. Did I make a mistake somewhere? Oh yes, I did. Ooh. I have to backpedal. I just see that this one is not going to turn out to an identity. And you might have checked with the problem from the book. I meant to do that right away to double check that I actually used the correct one from the book, and here's my mistake. I'm not going to repeat the whole problem. I'm just going to fix the mistake that I made. This doesn't say 1 plus cosine squared. It says cosine squared. And that will, of course, save our identity. So 1 plus cosine squared. Okay, that looks way better. 1 plus cosine squared. Saved myself here. I will make sure that in the next one that I double check that I actually did type it incorrectly. Well, at this point here, as that saved my identity, I recognize that as a Pythagorean, and therefore we're done. Right? 1 equals cosine squared plus sine squared. All right. When I teach math, it happens on the board as well, and as you see, it happens here in eLive as well, that I do make mistakes. They're not necessarily intentional, unless I really want to show something. We came across that a few times, that I wanted to show something, you know, this is the mistake you could make and this is how to pay attention. This time around, of course, a mistake that I didn't intend to, but it's part of that I read through my notes here and I'm typing at the same time and I'm thinking what's the next step and I'm thinking about what do I exactly say. So there's a lot of stuff that's going on in my mind and such an easy typo can happen. Anyway, that shouldn't disturb us. It still comes out that we did the right thing, and you also figure it out. Okay, let's do the next one. And this time around, I will double check it, and it looks correct the way I have it. This looks very complicated. I will not even read it out loud. It's too much for me to read. So let's see what we got here. Tangent minus cotangent on the left, and on the right, this one here. In the numerator, I recognize this right away as a difference of squares. So I may just use that. Maybe. I'm going to check my actually, I'm gonna check my notes. I have done this problem before, and even though I do recognize this as a difference of square, sine minus cosine. Let me show you. Sine minus cosine times sine plus cosine. I also recognize it as that it's not going to help me. I will get two fractions multiplied with each other, but on the left-hand side, I still have two trig functions being subtracted from each other. So I'm not going to use that actually. the way it's written right now is correct, but I will use the original one. And that comes from looking at my notes that this approach here of recognizing the easy difference of squares is not going to help me. So what I'm going to do instead is the following. I'll look at the left-hand side and say that this one is going to be sine over cosine. So I'm going to do that. Sine over cosine right here. Cosine. And this one is cosine over sine. Cosine over sine. Okay, what can I do with that? Well, let's see. So I use the ratio identities at this point. Now I'm going to cross multiply. Why do I do that? Why did I not use the difference of squares? Because I recognize, as I showed you a moment ago, that the difference of squares is not going to help me a whole lot, because I get two, on the right hand side I get two fractions multiplied with each other, while on the left hand side I still have a subtraction or difference. So instead I try something else, and I don't know it works because I did it in my notes before I did the example before. So I'm going to cross multiply with the sine times cosine. Let's see, times this one, and I put big parentheses around this one. And then on the right hand side, the fraction is gone. I'll try that again. There we go. And now I recognize that on the left-hand side, when I distribute sine and cosine, what I get over here is, well, actually, let me do that. Again, you might have to scroll a little bit up, so I get it here, and I get it there. And I don't need the parentheses anymore. Okay. Looks like a lot, so distribute. And notice on the left-hand side here, in the first term, sine squared and cosine canceled, so first term, cosine theta cancels. Second term, sine theta cancels, and of course this is supposed to be a theta. There we go. And then of course I have cosine squared, sine squared in the first term, and then cosine squared in the second term, and I can conclude that I'm done. Okay. This was quite a complicated one. I said there was kind of like a dead end here at some point with the trying the difference of squares. This time around it didn't work. Next time it will actually work. We have here difference of squares on the left hand side, and why will it work? Well, look at it. 1 minus sine squared, when I do the difference of squares, is going to be the same as the 1 minus sine over there, times actually 1 plus sine. So we're going to try that. So this one here will become 1 minus sine times 1 plus sine. So let's see, here we go. Times that plus, so we have difference of squares, then 1 plus sine t cancels on both sides. Okay. Actually, again, I'm going to double check that I have the right problem. And once again, I don't. Once again, I made a mistake in writing this down here. This is not the correct problem. I will end this problem with the correct one, but I'm going to stop myself after that and start the next problem section. Or the same problem, and continue the same problem sections. When I'm done here, I just need to regain myself. So this is not the correct identity. In fact, it's not an identity. This is the way it should be written. 1 minus sine t in parentheses squared. There we go. Okay, so we don't have a difference of squares. Okay, what happens now? Start over. What happens now? Well, on the left-hand side, I have 1 minus sine t times 1 minus sine t, which means it's the same as over here. I also have a 1 minus sine t. So one of the 1 minus sine t cancels. So as this one cancels here, I'm left with a 1. And as this one cancels here, I'm just left with one of the sine t's. So one of the 1 minus sine t cancels on both sides. I may want to write this like this here. And if I really wanted to, I can put a nicer negative in there, and it looks a little bit better. There we go. Okay. Let's see what's going to happen next. I would say I cross multiply. So as I cross multiply, I will come up with 1 minus sine t times 1 plus sine t. And then over here, I will have cosine squared right there. And then, of course, I don't need the fractions anymore. Okay. And then I use the difference of squares. And I will come up with 1 minus sine squared t on the left. There we go. And I recognize that as a Pythagorean, and I'm done. I will use the graphing calculator here on this one, as well as one of the others that we had. Just have to make sure that I use the correct one. I think this one and this one was the first one of this exercise, and then the first one of the other one that I had earlier. Okay, so let me go over to the graphing calculator, and with that one I will finish the first part of this problem section, and then regain myself and do the second part. Okay. So the one that we just did is 1 minus 1 minus sine, let's say 22 degrees, And that way actually needs to be in parentheses and then squared. So I need to put a parentheses in the front because it's a numerator. Divide by, I think I'll also put that in parentheses, cosine 22 degrees, parentheses, square that as well. Hit enter, 0.454. And then on the right hand side we have 1 minus sine 22 divide by 1 plus sine of 22. Oh, yeah, that's correct. And we come up with the same. So the last identity that we just did is indeed correct. The identity from the example before looks as follows, parentheses 1 minus, I'm going to put parentheses around it as well, sine of 11 degrees, just faster to type, parentheses, and that one was actually to the 4th power, parentheses, that's the numerator, divide by, I'm going to count the parentheses so that I have enough of them, divide by 1 plus sine 11, and actually I will put that in parentheses as well, sine 11, parentheses, square, and the parentheses for the denominator, and I come up with this one. And then on the right hand side we have cosine of 11 degrees, which is pretty close to 1, and that should be squared, so it stays pretty close to 1, and indeed it's the same as the left hand side. With that one I'm finishing up this first part of the problem section, and as I said, regain myself, double check my problems here for the letter part, and then return. Okay, welcome back to the second part of this problem section for proving identities. And I double-checked that this time around I don't have any typos. I don't, which means in a moment I'll be triple-checking. I have written down the same identities in 4 different places, maybe even 5, on a printout here on the screen, which is the important one, in the book and in my notes as I calculated. So it's kind of a bummer that I had that typo in there, a couple of them. Okay, let's go on. The next identity that we're about to prove is 1 plus cosine over 1 minus cosine equals cosecant plus cotangent, and that all squared. Check with the graphing calculator. I already did one for these examples and included it in the script. So I'm not going to do that here, but I'm going to do that on the next examples after that. Okay, let's get started. On this particular one, there are several ways of doing it respectively. The first one that I come up with is actually, I don't have much of an idea what I can do there. So I just figured that change everything to sines and cosines and then go from there. So as I change everything from sines to cosines, of course, this one is going to be 1 over sine. 1 over sine x, and this one is going to be cosine x over sine x. Okay. What now? Now, of course, I could take this whole parentheses and square it, and with a perfect square trinomial, but that looks like I get a lot of terms. Maybe it's unavoidable. However, what I do see is that I have sine x in both denominators, so I might as well combine the 2 fractions. So combine fractions on the right. And then, of course, I have 1 plus cosine x over sine, 1 plus cosine x over sine, and everything squared. And I believe I'm going to write it like this here with the square right there, parentheses here, and a square right there. There we go. There we go. Oh, well, that looks pretty nice, because now I can see that as I combine fractions on the right, that one of these 1 plus cosine is going to cancel. So 1 plus cosine x, one of the cancels on both sides. So I'll do that, which means on the right-hand side, one of the plus cosine is going to survive, and on the left-hand side, since this cancels here, there's a 1 left. Okay. I would say I cross-multiply to get rid of the denominators. So in cross-multiplying, I'm going to have the sine squared over here, and then this one is being multiplied on the right-hand side. And I'll put a few more parentheses in here, and I got rid of the fraction bars since I don't need them anymore. Same over here. There we go. At this point, I can already say that, well, the way this word will turn out is that I have a difference of squares on the right, which then will turn into a Pythagorean, and will be done. So difference of squares. And with some practice, you also are able to see that relatively quickly. So it's going to come out to 1 minus cosine squared on the right-hand side, as we combine this here from the difference of squares. There we go. And now we can say, well, that's a Pythagorean. And we're done. Difference of squares. Okay. Next exercise. Prove that this identity is true. We should be able to see that on the left-hand side we have a difference of squares. So we're going to take the to the 4th power apart. I should find an abbreviation for difference of squares. We're using it so often. But I had mentioned that in the guidelines to the lecture, during the lecture, among the 6 guidelines, that difference of squares is one of the important ones. So on the left-hand side we have sine squared minus cosine squared times sine squared plus cosine squared. So we're going to do that here. Times, parentheses, parentheses, plus, parentheses. Okay. Well, there's a Pythagorean right there, the second parentheses. Is of course 1. So that was nice that this one here comes out to exactly 1. And then of course I don't need to write anything of this on the left except this one here, sine squared minus cosine squared. Get rid of all the parentheses. Okay. At this point, looks more complicated than what it really is. I'll just add 2 cosine squared to both sides, and you will easily see that again we have a Pythagorean. So add 2 cosine squared a to the left, and then of course a square. So I'm going to do that. That of course means as I add that from the right. Of course, it's gone here, added to the left, which means we have a negative, negative one of them, add two of them, we come up with a positive one, and that couldn't look any easier. Of course, that's a Pythagorean. We're done. And I don't really have to write down Pythagorean because you should be able to see that. This one here should be exactly the same as the one up there. So I'm just going to write ditto the steps here and just going to do the algebra here without further ado, without even describing anything. You should be able to see that from the last example. And there we go, we're done in the same fashion. I'll be checking, let's say, the first of these two exercises here with the graphing calculator in a moment, but let me do the next example here so that we can do everything at once. So let's see, prove that this identity is correct. Let's see how to attack this one here. Again, there should be several ways. Looks like nothing of this here is a difference of squares, obviously. I could switch everything to sines and cosines. In fact, those are the only ones that I don't have right now. Let me just try something else instead. I just factor everything on the right hand, on the left hand side. Actually, I FOIL the left, and let's see what we come up with. So it's going to be tangent squared plus 2 tangent cotangent plus cotangent squared. So I'm going to do that. Tangent squared plus cotangent squared, and in between is plus 2 times tangent theta cotangent theta. There and there. And then, of course, we just squared everything, so we get rid of all of this. There we go. Okay, what will that do for us? Well, the one in between here, tangent and cotangent, those are reciprocals of each other. So it's going to be sine over cosine times cosine over sine. So it's going to be simply 1 times the 2. So I'm going to write that one down. So as I said a moment ago, these are reciprocals of each other. So tangent times cotangent is 1. So we just have that 2 there in the front. Let's see how that one compares. Let's see how it compares. What can we do there? Oh, here's something new. Actually, I will write this down here. Tangent theta times cotangent theta equals 1. And write these down here. There we go. Okay, here's something that we haven't used. There's actually Pythagorean in here. Do you see the sine squared plus cosine squared? Obviously not. But there are a couple other Pythagoreans that that we know of, even though we hardly ever come around them. And they're right here. That secant squared minus tangent squared equals 1. And that cosecant squared minus cotangent squared also equals 1. So I'm going to get these to the other side. So I'm going to say that I have secant squared minus tangent squared, and I have cosecant squared minus cotangent squared. And actually what I should write here for my step would be subtract tangent squared and cotangent squared on the from the right to achieve, in this case, two Pythagorean identities. I'm going to do this one here and switch this one here to theta. There we go. Looks a little better. Okay, so what we have here is, I'm going to scroll this a little up because actually it's off my screen. So I have secant squared minus tangent squared, which is 1, and I have cosecant squared minus cotangent squared, which is also 1. So as I copy this down here, whoops, there it is. So this one is 1 Pythagorean identity, and this one is 1 Pythagorean identity. And now we're back to basic arithmetics, and we can see that, of course, we're done with this one. Okay, at this point I'm going to go to the graphing calculator and we'll use check numbers for this particular example or exercise, as well as for the sine to the 4th power minus cosine to the 4th power that we had early on. Let's do this one here first on the graphing calculator. All right. So I said we're going to do parentheses tangent, and I'm going to double check the mode here. I am in degrees, so tangent of, I don't know, 33 degrees plus cotangent of 33 parentheses square that. That's the left-hand side of the identity, 4.79. The right-hand side is secant, so 1 over cosine 33. Square that. That's why I put the parentheses around it, so I can easily square. Plus 1 over sine 33. Close the parentheses. Square that. Enter the same. When you type that in, of course, you have to make sure that you type it in correctly. So far, I haven't made a typo. If you see that the two don't match up, then you have to look in there, well, where's my typo? Did I make a mistake there somewhere? I will do that, actually. I will make a mistake, a typo on the next one, so that you can see that what could possibly happen to you and how to fix that. I'm going to save this here as a screenshot for myself so I can edit it later. Okay, let's do the next one. So here I'm going to do sine. Actually, I will do parentheses sine 11 degrees parentheses to the 4th power minus, I actually do it correctly here on the left-hand side, cosine 11 to the 4th power, and that's what I come up with, negative 0.92. Kind of makes sense that it should be negative because the sine of 11 degrees is rather small, the cosine of 11 degrees is rather large, so when I subtract a large number from a small number, I should come up with negative. Okay, the right-hand side, and this is where we'll make a mistake on purpose, so minus 2 cosine, and let's pretend that I forget about the square in there, and think that, ooh, this is the identity, hit enter, and oops, I don't come up with the same answer. So now I'm going to search for my error, and I look back here at the identity and say, oh, the right-hand side should have been 1 minus 2 cosine squared. So I'm going to go in here, second entry, and I fix that by putting a square in the back. But it also means, well, I could have also written it like this. just square. But that also means I have to put a parentheses right here. So I can insert parentheses, hit enter. And now that's exactly the same result as I had earlier on. Again, I'm going to save this one here as a screenshot so I can insert it later. Okay, let's go back to Word and do the last few examples. So what I just did on the calculator was just to show you that if you encounter a mistake as a simple typo there, be confident and check the way you have it typed in on the calculator. It's very likely that you discover a typo. Okay, on the last two exercises, we're supposed to just use the graphing calculator anyway. So I'm going to do that and just go back and type them in, and let's see what it says here. The following identities. Use your graphing calculator to determine if each equation appears to be an identity or not by graphing the left expression and the right expression together. So I'll be graphing secant b minus 1 times secant b plus 1, and then I'll be graphing tangent squared b. And on the second one, I'll be graphing this one here. Let's go over. Okay, clear this, go to y equals. The left-hand side said secant, so 1 over cosine minus 1 times secant 1 over cosine plus 1 and I graphed it. Before I graphed it, I'm going to change to radians so that I can operate with small numbers. Then I'm going to go to zoom, and I'm going to do z standard, and let's see what we get. Okay. Okay. That looks kind of interesting. Okay. No negatives. All right. Go back to y equals. And the second one, the right-hand side said tangent squared. So tangent squared. And of course, if it really is an identity, we wouldn't really see anything happening on the screen. So what I'm going to do is, because it would just graph right over the other one, but if I make it bold, then at least it still graphs over the other one, but at least we can see that something is happening. So now I'm going to hit graph. And sure enough, the right-hand side equals the left-hand side, as we can see that. This is actually not a proof. That's why it says in the book that it appears, if it appears to be an identity or not. It just shows that, hey, in this interval, it sure looks like it's an identity. Okay, I'm going to go back to Word. Actually, I will make sure that I save this one here. Okay. So, yes, this, let's see, do I call this equation? This equation appears to be an identity as seen when both left and right hand sides are graphed. Okay, let's try the other one. So secant minus cosecant, and then cosine minus sine, and so on. Let's go to the graphing calculator. Okay. Y equals, I'm not going to erase these first ones here, maybe I need them later. Okay. I just de-highlight them, so it's going to say secant, which is 1 over cosine, minus cosecant, so it's minus 1 over sine, and then we graph. Okay. Whoa, that looks really kind of interesting. I just say because I rarely get to see this kind of thing. All right. Whoa. Let's try the other one, the right-hand side. Okay, and it says numerator, cosine. That's why I put a parentheses, because I have a numerator now. Cosine minus sine. Close the numerator. Divide by. Put a parentheses around the denominator. Cosine times sine. Close the denominator. Again, I'm going to graph this in bold. Okay, graph. And that sure does not look like the same. Actually, it looks just as funky as the other one, but it's definitely not the same. It must be somewhat upside down or so. Actually, we could actually make an identity out of it if we, I believe, turn the use the reciprocal on the right-hand side of that non-identity that we have here. Whoa, this looks really kind of interesting. I'm going to do a screenshot so I can insert it later. I may want to double-check here in my equation editor and make sure that truly the left-hand side is the same that I wrote that is given in the exercise, and the right-hand side is definitely the same that was given in the exercise. And I double-check that right now, and that's exactly what it says. And the solution in the book also says that this should not be an identity. So we're going to go back here and write down that answer. No, this equation appears not to be an identity as seen when both left and right-hand sides are graphed. And with that one, we're finally done with the problem section for proving identities.